There are three main transportation modes: light-duty vehicles, trucking, and air. Light-duty vehicles make up 60% of fuel consumption in the U.S. transportation sector. Trucks make up just under 20%, and air transportation uses about 10% of the fuel total. Rail, marine, defense, and pipeline transportation make up the remaining 10%. The average efficiency of the light-duty vehicle fleet is expected to double by 2035 with existing technology. Trucking and air transportation are projected to improve in efficiency 20 to 30% by 2050. Therefore, efficiency gains of 30 points come out of the LDV share, 5 out of trucking, and 3 out of air. So it is within reason to get a 40% reduction in the transportation energy consumption figure through technology implementation. It has been said that the biggest oil reservoir in the world is the empty seats of American cars, 10 trillion empty seat miles annually. Increasing occupancy has been a losing battle as both transit and carpooling have declined. Conversely, right-sizing vehicles to their use would be greatly facilitated by the parkway grid, as the maximum vehicle size for parkways would be a light truck or minibus. Even greater reduction awaits on the bikeway grid. Single occupancy vehicles with a maximum speed of 20 miles per hour would weigh less than 500 pounds. This strategy is the inverse of transit. Transit, until now, tries to cram more people in per vehicle. The Parkway City slashes empty seats. LDVs with 40 miles of electric range can electrify about 60% of miles driven. Even cheaper e-bikes with a 10-mile electric range could electrify about 20% of miles driven. Maximum fuel efficiency is attained at 45 to 60 miles per hour. Creating a parkway grid would result in up to 75% of all miles being driven at a consistent speed of 45 to 60 miles per hour, without the stop and go of traffic lights, and congestion. The Parkway City places heavy freight destinations adjacent to freeways. This would reduce trucking travel time and low efficiency miles driven. Trip planning and route efficiency improvements result from the direct routes and walkable grid of the Parkway City. Total savings of up to 15% of transportation energy use result. With a significant shift to ride-sharing and minibuses, 25% of vehicle miles traveled would be suitable for transit, with 33% reduced fuel use per passenger mile. Business-as-usual rail and bus transit investment, by contrast, would increase both capital cost and energy consumption. As shown in the graph, bus and rail transit taken together use about as much energy per passenger mile as passenger cars. The higher density environment of the Parkway City improves mobility by making destinations more proximate. In this example, density would change from about 5,000 people per square mile to 8,000 people per square mile, a 60% increase. Yet the amount of private and adjacent green space is the same or more. In other words, the population density has increased dramatically, while paved area has been swapped for buildings. The standard of living remains the same, as privately owned living space is the same. This increases proximity enormously. 60% more local destinations are now within walking distance. Vehicle miles traveled would reduce 12 to 15% due to trip planning efficiency, land use and infrastructure development, employment concentration, and mixed-use synergies. The Parkway City achieves renewable, low-carbon emission, fuel self-sufficiency for North America by 2061, while increasing mobility and living standards. Next month, the 2011 edition of Building Green Cities will be available for download at parkwaycity.com. Thank you.